resume it just in case. All right, so HNO2. Okay, so we know it's an acid because it starts with H. NO2 is what? If you look up in your polyatomic ion sheet, you will see that NO2 is nitrite, right? And nitrite, ite changes to OUS. So I'm just going to type it in here next to it. This is nitrous acid. You see? Nitrous. Okay. This one right here, you notice it says gas. So this is just hydrogen chloride. It is not hydrochloric acid. Hydrosulfuric acid. Okay. Again, we need to make it. So we need to put H plus. Oops, that was horrible. Oh, come on. Give me my eraser. Okay, sorry, that was terrible. That H just became who knows what. All right, so H plus, and okay, so it's saying sulfuric. So that means it comes from sulfate. Sulfate is SO4 negative 2. So when we crisscross, right, we get H2SO4. And this one, like I said, binary acids need to be in aqueous form. Ternary do not. What is that last one? Can you, I can't see the actual formula, HCRO, what? Can't see it, it won't move. Okay, let me see here.
H2O4.
O4, okay, so that's chromate. All right, it could have been something else, so that's why I wanted to make sure. Okay, so hydrogen and chromate. Okay, again, that's an acid. Chromate becomes chromic, so that is chromic acid. And I'll just put it right here. Okay. All right, this next one right here, you can see there is hydrogen again, so it's an acid. And SO3 is sulfite from sulfite, right? So where's my L? Sulfite, change the ending of I to OUS, and then acid, okay? And then hypochlorous, okay? See how it's telling me what is my companion to the H? All right, so in this case, the H is going to be there, and then hypochlorate. So hypochlorate is ClO4 negative. Therefore, this is HClO4. And that's it. HI, and notice it says aqueous. So that is definitely the acid. And to name these types of acids, we use the prefix hydro, right? And that is iodine. So we use the iode part, put ic, and then acid. So hydroiodic acid. And the next one, that one, I don't know why it's there. It shouldn't be there. I think it's just me having extra. Oops. Nope. Undo that. Oh no. Undo it. Or there. Sorry. Okay. So this next one is H2S. Is gas. That is not the acid. So the name of it is not acid. It's hydrogen sulfide. Very simply. Just like the other ones that we were naming. And you notice that these, and if you say disulfide, dihydrogen sulfide, that'd be fine with me. Normally, when they're acids, they don't use that whole nomenclature stuff, but dihydrogen sulfide is the actual name. When you look at it, just like water is dihydrogen oxide, which is true. All right. So this guy right here is the next acid that we have. What is C2H3O2? Look it up in your polyatomic ion and tell me. C2H3O2. Anybody find it?
You said at the top in our
No,
names?
no, in the polyatomic ion sheet, there's a name in there somewhere that tells you what C2H3O2 is.
Oh, it is acetate.
Okay, so 8 changes to
I'd
ick, not an
it.
acid. Yeah, sorry, I said 8. 8, sorry, 8 changes to ick, so it's acetic acid. See? What is the next one? I can't really see I see it's HPO something, but I can't really see it. Is it PO4 or
Oh
PO3?
wait.
Or is it even P? Because it could be B too. And I don't see anything beyond the little
What number is it? 50.
50.
H3PO3.
Okay, so that, what is PO3 in your polyatomic ion sheet?
Mm, must be what I cut off.
You just had it.
I don't see PO3.
It should be PO3, 3 negative.
Oh, phosphite.
Mm-hmm. Okay, so phosphite, take the ide ending, right, and put phosphorus, OUS, acid. See, they're pretty simple as long as you have to learn to recognize them. Once you recognize them, you know who they are. All right, so let's clear all of those that we did and go to the next, sorry, all of them, and go to and see if there's any more behind that because I couldn't see them. I know there's yeah, there's boric acid. There's one more. 34, boric acid. Okay, so boric acid is hydrogen, obviously, right? Because it's boric acid, so it's, oops, what did you do? Nope. Whatever that was, it didn't mean to do that. Go back. Okay, I just bring it back out. I just bring it back out, that's all. No, not the polyatomic ions list. 50 ways, there we go. All right, so we were looking at boric acid, right? Ic meaning it is an 8. Remember that? How we do that? Okay, so when you have boric, you have to look for borate. All right, so borate is what? Can you find it in your polyatomic ion sheet?
BO3 negative 3.
Okay, there you go. So what we got to do is write down, remember, we know how to put compounds together already. So you got H plus and BO3 negative 3, which when we crisscross, remember, this goes down here and this goes over here. So we got H3BO3. And there is your boric acid right there. And that is how you make acids of anything. You just kind of put the hydrogen in front, and you know hydrogen is a plus. So everything else follows after that. All right, so now we have been doing these, and yes, a lot of people need more practice, and I know that. So we are going to do that. There are some extra sheets right here. And I think I've got them backwards. It says formula to name and name to formula. I think this is the opposite. Yeah, this is name to formula. Okay, so name to formula. I don't know why I just did, but I do have them backwards. Okay, so, ooh, come here, you. Why do you get smaller? I made you bigger, not smaller. Okay, so copper 1 oxide. You see how the name itself is telling us what to write. Copper 1 is Cu plus. So we know that. So we must write Cu, oops, okay. Why are you doing this to me today? Come on. Okay. Cu plus. And then oxygen, right? Because oxide, IDE, is telling me that's oxygen just by itself. So O2, no, sorry. O is normally a -2. So when we crisscross, we get Cu2O. And there's your copper 1 oxide. Aluminum hydroxide again. See how it's just kind of, it's what it's pretty much telling you what the components are. You just got to write the ions. Oh man.
So so like you see how the hydroxide is at the end? Do we still put the H first? Or
You
no? We put
always
it in.
put the positive first.
Okay.
So aluminum is aluminum, and this is the ion that we have to write. And so this is going to be your, oh man, why does it do that? So annoying. That's why I started doing it with the, okay, come on. I started doing it with my, it takes longer, but I started doing this with my mouse because it started doing that crazy stuff, and it's not as pretty either. That looks like a 5. But that's a 3. I'm writing with the mouse. Okay, so aluminum 3 plus, and hydroxide is just OH negative, right? So we know that. Therefore, we crisscross and we get Al. Maybe I can write this down now. AlOH3.
-3.
No,
Or
no
just
negative. Remember that they crisscross, and then the reason
oh okay.
that we crisscross them is so that the compound has absolutely 0 charges, because it's an ionic compound. It should be neutral. Now, the next one that we have with the name with tri in deca, we know what to write. Phosphorus, what is tri? Well, according to your prefixes that we learned, tri is 3. So P3. In deca, think of decade. That's 10, right? S10. And there you go. These are covalent compounds right here. This is a covalent compound. All of these have been ionic so far. Okay. All right. Zinc nitrate. Again, just write down your 2 things. You got your zinc. I'm trying to write it with this mouse. It's a little harder, like I said. And zinc is +2. And nitrate, you got NO3 negative, right? So when you do your crisscrossing, the negative's up here. So when you do your crisscrossing, the 2 goes to the NO3 and the 1 goes to the zinc. So the zinc doesn't need a subscript, but the NO3 needs its parentheses and N, oh, Lord. I'm trying, like I said, I'm writing with this ×2. So see, NO3, it's one thing. So you multiply it ×2. Hydrobromic acid. Well, we just did all these acids, but it's easy to know that hydrobromic, it's hydrogen and bromine. And hydrogen, bromine, it's negative. Therefore, oops, negative up here. Thank you. So we get an HBr. And if this is an acid, then it needs to be aqueous. Remember that part, because that'll be part of what you will get in your connect things that you're going to do. So it needs to say AQ like that. All right, mercury 1 bromide. Okay, mercury 1, it's telling me write down Hg plus because it's telling me 1. 1 means plus 1. So Hg plus, and bromine, just look it up in your periodic table and you know bromine is in group 7, therefore it's a -1. Well, then that's easy, HgBr. There you go. That's it. Boron tribromide. Okay,
So
boron.
every time it ends in acid, we add the AQ.
No, not every acid. Only the binary. Only when there's 2 elements. When they got the hydro prefix.
Okay.
Right? Only then. Yeah. Okay, so boron tribromide. Okay, so it's telling you what to write. Boron is B, right? And
Mm-hmm.
bromine is Br, and it's saying 3 of them, right?
Mm-hmm.
Because tri means 3. That's it. That's a covalent compound. See how much easier they are? Okay, so this is covalent. No, this is ionic, sorry. This is an acid, which is really a covalent compound. This is ionic, and this is a covalent. And you have to identify which one's which, because the rules for naming are different. So if you don't know that, then you should. You know, how do you know it's an ionic compound versus a covalent? It starts with a metal. That's how you know. Copper is a metal, aluminum's a metal, zinc is a metal. That's an acid, so we're not looking at it. Mercury is a metal. Now, how do we know it's covalent? Well, it starts with a non-metal, or it has a prefix, one of the two. I mean, if you see a prefix, because it's a name already, then you know it's what it is. And this is boron. Boron happens to be a metalloid, and remember, they can have properties of both. So in this case, it acts more like a metal, a non-metal than a metalloid. All right, so let's clear all of these and go to 8, 9, 10, and 11. And we don't have to do every one of these, but let's see, we're going to 18 on this one. Okay, so so first, if you had to identify them, let's just say we're going to stamp on this for ionic, right? So we're just going to do ionic like this. And this is ionic, by the way, because it starts with ammonium, and ammonium's an ion. So chromic, okay, that's an acid, that's an acid, that's not, and that's one. All right, and let's say we're doing a star for covalent. So covalence, it's this one and this one so far. And then let's say we're doing a heart or whatever for acids. So this obviously, it's got the word acid on it, so it's obvious, right? All right, so now we know how to name them. See, okay, so how do we know how to write sodium hydride? IDE tells me that this is the single element of hydrogen, that ending. So I know that this is going to be comprised of sodium positive, right? Oops, sorry, this is horrible, but I'm writing with the mouse, like I said, and the hydrogen. In this case, the hydrogen is after, so therefore it is the negative one. Okay, so when you put it together, it's just NaH. And that is sodium hydride. Okay. Now, barium perchlorate. Okay, so it's telling me to write two things. Barium and barium B8 is in group 2, so we know it's a +2. And perchlorate in the polyatomic ion sheet is ClO4 negative. Like I said, I'm writing not with my fingers, so it fits a little better. All right, so crisscrossing, this gives the barium the 1, right? and the perchlorate gets the 2 from the barium. So ClO. Oops, that's a no. 4 negative. Okay, and that is it. And then times 2. All right, now, when you're looking at this, if you want to know what the purpose of it is, see if you multiply this whole thing times 2, right? You multiply this whole thing times 2, it becomes a 2 negative, right? And 2 negative and 2 positive cancel out. And this is why you have to multiply it times 2. That's why we crisscross the valences, because it tells us how many. Okay, tetra means 4 and hexa means 6. So it's telling us there are 4 phosphorus and 6 sulfurs. That's the easiest one. And no, we cannot, since this is a covalent compound, we cannot simplify. We do not ever simplify. Now, sulfuric acid. See how there's no hydro in front of it? So since we know it's an acid, it's the H plus, right? And the SO4 to negative, because sulfuric, ic comes from 8. All right, and when we put it together, it's H2SO4. Things with this thing. Okay, there we go. There, okay. Calcium hypochlorite, okay? Again, it's telling me what to write. Write down the calcium ion, right? Ca, and it's in group 2, so we know it's a +2. And hypochlorite. Hypochlorite is ClO negative. So when we put it together, again, crisscross and all that good stuff, we got Ca with the 1 from the hypochlorite, and ClO gets the 2 from the calcium. And that's why we put it in parentheses, is because that is a unit, you know, a one thing. Okay, now this is 2 ions, and it's telling me exactly what to write. So I write ammonia. Ooh, okay. Why did you keep writing? Undo that big old line. There we go. Write ammonium. And that's an ion. It's one of the polyatomic ions. As a matter of fact, we made sure that we knew that this was the only positive one there exists, right? And phosphite is PO3 negative 3. And the same thing applies to this one. Crisscrossing, right? And we get, and that's a negative, it's kind of hard to see it because I wrote right on top of it. So the NH4 gets the 3 from the phosphate, and the phosphate gets the 1 from the ammonium. So it's ammonium times 3 and phosphite, because it's PO3. Oh, Lord. Oh, 3. There you go. All right. So that's how you do all of these. And it's pretty obvious that what they're telling you to write is what you're writing. Okay, I'm going to skip that one. Let's do hydrosulfuric acid. Okay, so you notice the word hydro is in front of it, which means this is the binary acid. Okay, so hydro, that's hydrogen, and sulfur is in group 6, so it's a -2. So when we crisscross, we get H2S. But remember, since this is binary, this is what you were asking about, Kashun. Since this is binary, we get aqueous. Otherwise, it's not the acid. Okay? And there you go. All right. All right, let's do this one. Phosphorus pentafluoride. Remember, We don't need to put mono in front of it to make sure that that's 1. So just the name itself is telling us there's 1. And pentafluoride means 5, right? Penta is 5, so PF5. See, it kind of tells us what to write each time. I'm skipping around now because I don't want to do every single one because, there's no need. Let's go to the next ones. Clear. And we have 7 more because this is a total of 25. So, all right, 19. Okay. So again, to classify them, we are going to do the acids. There are none. Okay, so we are going to do the covalents first. There's one. That's a covalent. Oh, there's an acid. Sorry, I missed that one. Phosphorus acid. I forgot about you. And we said we were going to do those. Oh, and there's another acid. I see you. Jeez, I'm blind. Okay, there. And then the rest are covalent. So we could just put a check on those. So these are ionic. Sorry, I meant to say. All right. So magnesium sulfate. See, it's just telling me, right? Magnesium, right sulfate, do your crisscross, and you've got it. Strontium phosphate, same thing. Dichlorine monoxide. Okay, di means 2, mono means 1, right? So you just write down what it's telling you. Dichlorine, that is Cl2 monoxide. Oh, Cl2O. That's it. Phosphorus, OUS, acid, is telling me to write down the hydrogen because it's acid. And the phosphorus comes from phosphite, right? So write down PO3, -3. And then crisscross, and you've got H3PO3. And this one doesn't need the aqueous because it is a ternary or oxy acid. See? Disulfur dichloride. So 2,2, S2Cl2. Iron 2 carbonate. Oh, sorry, iron 3 carbonate. It's telling me to write down iron 3, so Fe3 plus, right? And we have that one. And then carbonate, which is CO3 -2. Sorry, this is horrible. I'm getting worse because I'm trying to hurry. Okay, so when you crisscross, you get Fe2. Trying to do this one prettier. Oops, that didn't work. Fe2, and then CO3 times 3. And the last one, perchloric acid. So perchloric, ic comes from 8. So the name is perchlorate. So ClO4 negative. Oops. I know it's all crazy, but and that gives me HClO4. And that is all of those acids right there. See, sorry. LO. There we go. All right, so that's all of them. That's all of those. Now, people say, ooh, so let's do the other way, because this is the easy way, believe it or not. These are the easy ones. To me, the hardest one, this is my opinion, is to write it when it's a formula, because they're not telling me what's what. So let's go back. Okay. Let's go back to where this one came from. And we're going to do the other one. Name to formula, which is backwards. I don't know. I need to correct it, but it's just weird. I don't know why I put the ones in the wrong one. Okay, so this is all going to be formulas. This is a little bit harder. Why? Well, In a way it is, in a way it isn't. But when they're easy, like this one, you know, you just say potassium and then SO4 is sulfate. That is an easy one because it's just the two ions. This one's easy too because it is a a covalent. So di-nitrogen, and then it's tetra, right? Because it's 4 tetra. So, sorry, tetroxide, and there should be a there. All right, and then this one again is an easy one because barium is not a transition metal, and that's perchlorate. So perchlorate. That was easy. This is an acid. You can look at it and you can see this is nitric. No, it's nitrous acid. Oops. Yeah. OUS acid. How do I know? Because that's nitrite. Okay. This is the one. This is where we get confused a little bit. Okay. So we need to rewrite down at least the SO4 and do compound math. That's what I call it. So let's just write them over here. I'm going to try to do finger again, see if it'll work. Oh, nope, it's not working. See, it's just, I don't know what it's doing, why it's doing that, but I'm just going to have to do it with my mouse again, which is a little harder than you think. Okay, so Fe2, and you notice I am decomposing the compound. SO4, and then we have this times 3, right? So what is SO4 normally? Well, SO4 is normally a -2, right? So if you multiply this times this, that gives you a -6. And don't look at the negative, just look at the 6. Divided by this 2, and that gives you 3. So you know that this is iron 3, and now you can name it. See, that's what I was telling you. It makes it harder when you do that because of, and then the other thing is sulfate. This one's ammonium. See, this one's easy because it's ammonium fluoride. Okay. Why is it fluoride and not fluorate or anything? It's because it's the single element. Single elements are IBE. Barium, oops, barium iodide. See, this one's easy. Okay, Cr2O3. Again, another ion that could be anything. So let's decompose it. We know that chromium, we don't have really a clue of what it really could be. So what we're going to do is we're going to write it separately. I'm going to see Cr2, because this could have been simplified, and this is why it's a good practice to do what I do. And write the O3 by itself. And O3, O is always a -2. So when you multiply the 2, you get 6 divided by this one, right? Gives you 3. So you know this is the +3. Now you can name it as in chromium 3 oxide. And let me go back to my 10. Okay, so this is chromium oxide. And don't forget to put capital letters there because it might not like it. Okay, how do we know this one? Again, this is another one of those. So we need to decompose it again. We need copper. And there's nothing against copper, but there is 2 against this guy. So C2H3O2 is acetate. If we look at acetate, O2, we know that it's a negative, right? Negative by itself, yeah. And then times 2 gives me 2. So there's a 1 here, so we don't have to really divide. So this is a +2. So we know that this is copper 2. So now we can name it. This is what I call compound math. Because you got to do a little math to figure it out. Okay, this is silver, and silver is just a single. So silver, sorry, carbonate. I was looking at acetate still. All right, this is sodium hydroxide. Again, easy. 2 ions together, just name each one. Calcium, calcium is not one of those, so we just take calcium and phosphate. Ooh, phosphate. There we go. Cl, okay, so that's a covalent. So this is chlorine and, oops, where's my H? Chlorine, and the other one is tri, right? Fluoride. Fluoride. Okay, next one is potassium again. See, when they are easy, they're easy. Sulfate, sulfite. This is ite. Because 8 is the O4, as you can see up here, with the iron number 5. All right, but this is ite. This is aluminum. And aluminum is a metal again, and that's bromide. Bromide. And magnesium. Again, single element, chloride. See, these are super easy when they're not the ones that are the hard ones, the ones that have multiple valences so that you have to figure out the compound math. They're easy then. All right, so let's do the last few and we'll be done. All right, let's clear the drawings and go to the last, however many there are. What is it? 9? Yeah, because we were at 16. Okay, so the next one's an acid. How do we know? Hydrogen. So what is CO3, C2H3O4? O2, sorry. That is acetate. So again, acetate. Oops, why are you not typing? Sorry. Okay, right here. We were typing right here. So this is acetate. And remember, 8 changes to ic. And there's acid. P2O5, that is telling me diphosphorus. Phosphorus, sorry. Pentoxide, right? Pentoxide, because there are pentoxide. Okay, what is that? Pentoxide. Oh, I still did it again. Okay, there we go. All right. Again, this is iron. See, this is why we need to do this compound math. We are decomposing iron again. Okay, so we know we have iron, which we don't know what it is, but you notice it only has a 1. So we just write the Fe and the PO4, which has nothing either. So we just write the PO4, look for its charge, and its charge is -3. So we know that this is the +3 since it is 1, right? Now we can name it. See, this is why it's necessary, because otherwise it looks like iron 1, which by the way doesn't exist. Iron 3, phosphate. Yeah, that was the pH. Phosphate. Oh Lord, I cannot type today. Phosphate. Okay, yeah. All right, SRBR3. Okay, that's strontium. And bromine, so bromide. Bromide, strontium. Oh Lord, I guess I can type today. And aluminum. And sulfide. Sulfide, oh Lord. There, okay. IDE, because again, single element. Lithium, again, this is an easy, and that is bromide, bromine, so bromide. Lithium, there you go. And that right there, and yes, you could say that is nitrogen trihydride, which would be correct, but its actual name is ammonia. One of those that has an actual name. Okay, look at this lead. All right. Upon first inspection, you would say that's lead 2. But let's do compound math, and you will see that we are not right if we say lead 2. Why is that? because we have Pb, right? And we have O2. But what is oxygen normally? -2. So when we multiply these two, we get 4. So that is actually lead 4 oxide. See that? That is why we need to do compound math, because sometimes we have to decompose these things, and because simplification happens and decomposing it makes it easier. Okay, and this is magnesium oxide. Oops, oxide. There we go. And there you go. That's all of them named. Like I said, sometimes it's easier to name them, name to formula than formula to name. It's just, to me, it's easier the formula if you have the name to the formula, because they're telling you what to write. And sometimes the formula gives you the name directly, but there are those where you have to figure them out. And how do you know which ones? Okay. You weren't here for that, Kashanda, but I'm going to show you how you figure these out. Okay, so when you are doing these, oh, sorry, I got to escape this. Wow, just, yeah, just escape it. Escape. Oh, it's not letting me escape. All right, so let's just turn it off and let me just get rid of all that stuff in the mess that I made there. Okay, see right here, the naming compounds packet. This packet has something that you need. And this right here is a periodic table with common ionic charges. This is a really good thing to have when you're making compounds. Let me flip it over, because it gives you all the possibilities. Okay, there we go. All the possibilities. And the ones that are gray are never going to have 2. Okay, and so you know that if you have zinc, you don't say zinc 2. If you have aluminum, you don't say aluminum 2. But if you have manganese, you have to tell me whether it's the 7, the 4, the 3, or the 2. You see that? I need to know. And how do I know? By you telling me with the parentheses and the Roman numerals. So if I had chromium 3, and let's say chromium 3 sulfate, okay, that would be Cr plus 3 and SO4 2 negative. So the compound would be Cr3. No, sorry, I said chromium 3. So Cr2 SO4 times 3. See, that's how we would know. But if you did the math backwards to figure out what it was, then you could do that. And that's why the compound math is important. It's because we have so many choices in some of these that you don't know until you do know. You know what I'm saying? In other words, you don't know until you actually do the math. And the math needs to be done. All right, and that's it. That concludes the compounds for today and all of the compounds, period. So we are going to stop